non-linear equations. For that, let's understand some basic definitions, like what is a polynomial? What is a polynomial? Let's write a polynomial of degree n that can be written in the form a naught plus a1x plus a2x square plus a3x cube, so on up to a n x raised to power n is equal to 0. This is a polynomial. Now we can solve this polynomial. Let us suppose we have some quadratic equation. Now quadratic will be of the form a naught plus a1x plus a2x square equal to 0. Sorry, yes, a2x square equal to 0. Now we can solve this quadratic. How we can solve this quadratic? We can apply the formula minus b plus minus square root of b square minus 4ac upon 2a. And we can find two values of, here we have a as a naught, b as a1 and c as a2. Yeah, but you can write down in the order as a2x square plus a1x plus a naught is equal to 0. So if we take this equation according to this formula, what we have a means a2, b means a1 and c means, which is a constant over there, which is a naught, right? When you will apply this formula, you will get two values of x. Let us suppose the two values are alpha and beta. So this method is what? This is called the direct method. This is called the direct method. We have two types of method to solve any equation, a simple linear equation. Number one is direct method and number two is iterative method. Right? Now, what is the difference between them? This one is a direct method. What is the method? There is one formula. There is a single formula. We applied that formula only once. We applied that formula only once and we got our solution. We got our roots. These are the roots of this particular equation. Right? So, this is our direct method in which there is some particular unique formula. When we will apply that formula once, then we will directly find out the roots of the given equation. Clear? Now number two, second method to solve the equation is iterative method. Now what is that? In iterative method, what we do, there is some formula, there will be some process. We need to apply that process again and again and again up to the required accuracy is achieved. Now, what does it mean? Let us suppose there is some process. We applied that process and we name it as iteration number 1. Clear? And let us suppose after first iteration, we got the value of x as 4.96583. Let us suppose after applying some process, we got the value of x as this. Then we will apply the same process once again and that will be named as iteration number 2. Let us suppose after doing iteration number 2, our value became 4.97653. Again, we applied the formula that will be named as iteration number 3 and let us suppose we got the value of x as 4.9762. Now see, in the first iteration, value 4.96583. In second iteration, how many values are repeating itself? Before decimal it is same. After decimal, only one digit is same. See, 4.9, 4.9. Separate digits are different. Remaining are different. In the next iteration, what happened? 4.97. 4.97 repeat itself. 62. Let us suppose in iteration number 4, we get the value as 4.9765. That means 3 digits are repeated after decimal place. So we will stop our equation over here. What does it mean? We need to continue some particular process again and again up to the required accuracy is achieved. Sometimes in the statement we are given that up to 2 decimal places. Solve the given equation up to 2 decimal places. What does it mean? जब तक आपके 2 decimal place same नहीं आ जाएंगे, we need to continue. And sometimes in the statement we are given up to 3 decimal places या फिर up to 4 decimal places. So we need to continue with that process again and again until we required at the solution which is asked in the statement. Clear? So this is the iterative method. We are going to solve. Yes.
मैंने फिर से रिपीट करना.
We will deal with these methods only, iterative methods. In these methods, there will be some working rule. We'll see in the questions later on. There will be some working rule. You have to apply that rule once. Let us suppose after applying that rule, you got the value of x as this. You will again apply the same rule. And let us suppose in second iteration, you got the value of x as this one. Again applying the same rule, that means again applying the same formula. Let us suppose our value is this. Again applying the same formula, you got the value this. Now see what happened. Firstly, how many places are same after decimal? Before decimal, it should be same. But after decimal, how many digits are same? Firstly, only one digit was same, 9 and 9. All the remaining were different. Then we continued. Then we got 2 decimal places same, 0.97, 0.97. But let us suppose in the statement we are asked that you have to find answer up to 3 decimal places. So we can't stop here, na? Why? Because only 2 digits after decimal are same. But in the statement we are given up to 3 decimal places. That means after decimal 3 digits should be same. That means we will again continue the process. Let us suppose we got our answer as 4.976. Now see 4.976, 4.976. We have to compare two consecutive iterations. We cannot compare iteration number 4 with iteration number 2 or iteration number 1. We have to compare two consecutive iterations. And if 3 decimal places, that means 3 digits after decimal place are same. See 976, 976. Then we will stop our process here. And how we will write down our final answer? 4.976. Only the digits which are repeating itself. I think it is not visible. Let me write down over here. How we will write down our answer? X is equal to 4.976. Digits which are repeating itself. Non-repeated digit will not be written over there. Okay, now we will see in the example how to solve these type of equations. Now there are number of methods to solve. There are number of methods in which we are going to start with our first method, which is known as bisection method. So please write down number 1. Bisection method. Bisection, or it is also named as Bolzano method. It is also named as Bolzano method. B-O-L-Z-A-N-O. Now, what we are going to do in this method? This method is applicable when we need to find the root of an equation. Let us suppose we are given fx equal to 0, and what we are asked in the statement, find the root of given equation. This is our statement. Some function is given, fx equal to 0, and we need to find the root of given equation. Now, what does root means? What does root means? Let us suppose we have a quadratic as x square plus 4x plus 4 equal to 0. We are given a quadratic and our statement is find the root of this equation. Find the root of this equation. What will be the root of this equation? Can anyone tell me?
तो हम जेडी वैल्यू दे नाल x लगा होगा.
Exactly. तो आप इसको कैसे solve करेंगे? This can be written as x plus 2 whole square. Is it true? Let us solve it. A square plus b square plus 2ab. That means x plus 2 multiplied by x plus 2 is equal to 0. That means x is equal to minus 2 and minus 2. So these are the roots of this equation. Roots means, now let us substitute x equal to minus 2 over here. Let us put minus 2 square plus 4 into minus 2 plus 4 equal to 0. Minus 2 square, that will be plus 4. 4 into minus 2, minus 8 plus 4 equal to 0. That means 8 minus 8 equal to 0. That means 0 equal to 0. This proves that our answer is correct. Root satisfies the given equation always. Remember this thing. Whatever your answer is, it will always satisfy the given equation. So that value is called the root of the given equation. I hope it is clear to everyone. Now we are given some function. Now this function can be transcendental equation also. Please write down a word separately at the top of your sheet. Transcendental equation. Now what does this mean? Transcendental equation. Any equation which contains any equation, this can become definition of 2 marks also. Any equation which contains exponential function, logarithmic function, trigonometric function, hyperbolic function, etc. An equation which contains exponential function, logarithmic function, trigonometric function, hyperbolic function, and so on up to. Those equations are known as transcendental equation. For example, x e raised to power x minus sine x equal to 0. X e raised to power x minus sine x equal to 0. Now, can you solve this equation? No, we cannot solve. You need to find the value of x. How we can find? We cannot find. But we can find the root of this equation by using this method. We will see in our equations. Otherwise, we did 2 types of methods. Number 1 was direct method. Number 2 was indirect method. We did direct method was that where there is some quadratic. We apply the formula. We got 2 values. That is the direct method. Can we apply direct method over here? No, we cannot apply because there is no rule which can solve this equation directly. There is no formula. Solving means what? Finding the value of x. Can you find? No, we cannot find. But we cannot find such type of equations by using indirect method. Clear? I hope it is clear to everyone. If there is any doubt, you may ask.
Hello, ma'am.
हाँ जी.
मैम डायरेक्ट और इनडायरेक्ट कैसे होगा?
डायरेक्ट और इनडायरेक्ट के बेटा वर्किंग रूल्स होते हैं. I have given you one example of direct method. I have given you simple example of direct method. There is a quadratic ax square plus bx plus c equal to 0. When you will apply the formula minus b plus minus square root of b square minus 4ac upon 2a, you will get 2 values of x, alpha and beta. That means there is a single formula. You will apply the formula only once. सिर्फ एक बार लगाएंगे and you will get your solution. Clear?
Yes, ma'am.
A single formula, one formula, one time. Direct method. Indirect में क्या है? One process, but multiple times. Same process will be repeated multiple times. I hope now it is clear to you. This one is for direct. This one is for indirect. One formula, one time, we got our answer. But in indirect, there is some process, there is some working rule, and we need to apply that working rule again and again and again and again.
Multi-time.
Up to we reach at our required solution. Like this equation, we cannot apply direct rule over here. We cannot find our solution. So in these type of equations, we can use indirect method. And indirect method is bisection method. One of the indirect method is bisection method.
Okay, ma'am.
Okay, so we are given an equation fx equal to 0. How to solve the root of the given equation by using bisection method? See, there is some working rule. Step number 1, find two roots x1 and x2 you can write down such that fx1 multiply by fx2 is less than 0. Rule number 1. Step number 1, sorry. Find two roots x1 and x2 such that when you will multiply the value of the function of both points, it should be negative. It should be less than 0. Step number 2. Find x3. How to find x3? x1 plus x2 divided by 2. Step number 2. Then step number 3 is find fx3. fx3 means put x equal to x3 in the given equation. You will get fx3 in this equation. Fx equal to 0. You can mark it as equation number 1. Then step number 4. If fx1 multiply by fx3. See, there will be two cases. fx1 into fx3 is less than 0 or fx1 multiply by fx3 is greater than 0. There are two possibilities only. We have to multiply fx1 into fx3 always. It will be either less than 0 or it will be greater than 0. But if it will be equal to 0, then we will stop there. Right? Now, what is the first condition? If fx1 into fx3 is negative, this implies root lies between x1 and x3. First, we write down the wording as it is. I will clear it later on. That is, x2 will be replaced with x3. And if fx1 into fx3 is greater than 0, this implies root lies between x2 and x3. That is, x1 will be replaced with x3. Please note it down. So this is a working rule. This is for iteration number 1. When you will apply these 4 steps, iteration number 1 will be completed. Then same steps for iteration number 2. Again same steps for iteration number 3. Please note it down. Okay, let's understand these steps with the help of graph. What are the steps? I'm going to rub this such that. This one. Now, what is the working rule? See, it has x-axis, y-axis, or let's make over here this one, x-axis and y-axis. Now, see, firstly, what we will do? We will put x equal to 0, x equal to 1, 2, 3, 4 over here. We will continue up to when this condition is satisfied, that fx1 into fx2 should be negative. Clear? Let us suppose we got our two roots x1 and x2. Here, let it be x1 and here, let it be x2. Now, what is the condition? That the value of the function at these points should be opposite signs. That means if fx1, there is a curve. Let us suppose this is a curve. If fx1 lies down, then fx2 will lies in the upper side. That should be opposite. I hope it is clear. We found our two roots such that the value of the function on those roots are of opposite signs. Let us suppose this is our curve. Clear? So this is our point x1, fx1, and this is our point x2, fx2. Both should be of opposite sign. If x1 is positive, if fx1 is positive, then fx2 should be negative. Graph can be formed in this way also. If fx1 is positive, then fx2 should be negative. Then you can make the graph like this. It should be of opposite signs. Clear? So this is the first condition. This condition is applicable throughout the sum, throughout the statement, throughout the question, that these two should be of opposite sign. Now what is the next step? Find the midpoint. How to find x1 plus x2 divided by 2? What we will do? x1 plus x2 divided by 2. Now that midpoint will lie, let us suppose it will lie either over here or over here. We don't know the exact position. Let us suppose x3 lies over here. Let us suppose x3 lies over here. Now, value of the function, if it is negative, now x3 will replace either x1 or x2. I am again repeating. First interval is x1 and x2, the starting interval, x1 and x2. Then what we did, we divide x1 and x2 into two equal parts. How we divide? By using this formula, x1 plus x2 divided by 2. Now, we have to use this x3. We have to use this x3. This x3 will either replace x1 or x2. That means the new search interval will be either x3 comma x2 or x1 comma x3. What we are doing? We have to replace x3 with x1 or x2. When it will be replaced with x1, see, x1 की जगह पे यहाँ पे x3 आ गया, x2 remains same. But when x3 will replace x2, in that case x1 will remain same and x2 is replaced with x3. We need to do any one, either this or this. I have written in between or. Clear? Now how we will decide that x3 will replace x1 or x2? This is the condition. This is the condition. Clear? See, if fx3 is negative, negative means downside. If fx3 is negative, see, fx1 is negative, fx3 is negative, so both cannot lie on the same side, na? That's why we will consider x3 and x2. See, fx3 is negative and fx2 is positive. That means in this case, x3 will be replaced with x1 because both cannot lie on the same side. They should be on the opposite side. So that's why by using this condition, you have to find the new search interval. The new search interval will be either x1, x3 or x3. You can write down as like this, x3 and x2 this way, because x3 will replace x1, na? That's why x2 will remain same. Now let's start with one example. Perform 5 iterations. Perform 5 iterations of bisection method. Mark it as star. Step number 4. This is very important. Perform bisection method. Perform 5 iterations of bisection method to find the root of the equation. To find the root of the equation x cube minus 5x plus 1. X cube minus 5x plus 1 equal to 0. Now see, this is our fx. This is our fx. That means fx we are given in the statement x cube minus 5x plus 1. Now what is step number 1? Put x equal to 0, 1, 2, 3, 4 and so on up to. Let us put x equal to 0. What will be the answer? 0 minus 0 plus 1 equal to 1. This is positive. 1 is positive value which is greater than 0. Now let's put x equal to 1. 1 cube 1 minus 5 into 1. 5 plus 1. 1 plus 1 2. 2 minus 5 is minus 3 which is negative. See, sign changes. Here the value of the function is positive and here the value of the function is negative. So we will stop here. I hope it is clear to everyone. Let us suppose the value of f1 is plus 3. Let us suppose the value of the function at 1 equal to plus 3. It is again positive. This was positive. At 0, the value of the function is positive. At 1, value of the function is positive. Then we need to put 2, 3, 4. We will continue until we get the negative value. We will continue until we get the negative value. That means we have to consider opposite signs. Let us suppose at 1.
Ma'am,
Yes.
can we put in minus sign
Yes, we will
with 1?
go towards minus sign when all the terms in the statement are positive. See, let us suppose our statement is x cube plus 5x plus 1 equal to 0. Now, if you will put x equal to 0, 1, 2, 3, 4, 5, 6, 7 up to 10, all the values will be positive. And in that case, we need to move in the negative direction. In that case, okay?
Okay, ma'am.
Chaliye. Now, let us suppose we have f1 positive, f0 positive, f1 positive, f2 negative, right? In that case, we will consider 1, 2, not 0, 2. In our case, we are going to consider 0, 1 because our value is negative. But let us suppose if at the point 1, the function is positive, then we will move towards 2. It is negative. In that case, we will take 1, 2, not 0, 2. Two consecutive values we need to take where the sign changes. Okay. So, we are going to start from here, iteration number 1. Clear? x1 equal to 0. x1 is not 1. Please note it down. x1 is not 1. It is 0. And x2 is 1, not minus 3. It is the value of the function, but the root is 0 and 1. Also, fx1, you can write the value of the function once again. fx1. Now this is fx1, 1, and fx2, it is minus 3. Clear? So we have started our sum. We have started iteration number 1. Now, what is the next step? It is very important to take the correct values of x1 and x2. Otherwise, it will move into very big question, maybe of 4 to 5 pages. So, take it very carefully. Next step is taking x3. What is the formula? x1 plus x2 divided by 2. That means 0 plus 1 divided by 2. That means 0.5. Now, one more thing. We have started with the interval 0, 1. This is our interval actually. You can write in this form 0, 1. Clear? Your final answer will be in between 0 and 1. Remember this thing. Your final answer will not go outside these range. 0, 1, 0 point something will be your answer. Clear? Okay. So our x3 is 0.5. Next step is find fx3. fx3, function at the point x3. That means function at the point 0.5. Clear? Now how to find f0.5 from this fx? Highlight this and you can mark it as equation number 1. From equation number 1, it was x cube. Put x equal to 0.5 over here. So 0.5 cube minus 5 into 0.5 plus 1. One more thing, For this unit, you need scientific calculators. If you don't have, please arrange. Now, for the time being, you can use, if you have any calculator in your mobile or somewhere else, you can use. And the value of 0.5 which I have is minus 1.375. You can check, is it the value? It is minus 1.375.
मैडम फिर से रिपीट करना कैसी है ये वैल्यू?
fx3, we have to find fx3. What is x3? 0.5. That means f at the point 0.5. Now f, whenever you find f now, use equation number 1. Put x equal to 0.5 on the right hand side. 0.5 cube minus 5 into 0.5 plus 1. Clear? Please respond.
Yes, madam.
Okay.
Yes, madam.
So after solving this, you will get minus 1.375. You can verify. Okay. Okay. Now understand next step very carefully. Look at the screen only. बाद में लिख लीजिएगा. Now consider, it is very important step. Consider fx1 multiplied with fx3. We have to multiply fx1 and fx3. Clear? Now see, we don't need the value. We don't require the value. We need to check whether it is positive or negative. This is the only thing. Now what was fx1? This one, see, positive. fx1 is positive and fx3 is negative. So when you will multiply fx1 into fx3, your answer will be negative. Is it true? Positive into negative is negative. You don't require the value. We only need the sign. See, fx1 was positive. You can put your finger. fx1 is positive. fx3 is negative. When you will multiply both of them, you will get negative. Clear? Now, see the working rule which we have written, that when fx1 is multiplied by fx3 and you get negative value, then what we will do? We will replace x2 with x3. You have to remember this thing because it is satisfying. This is the basic condition that function should be of opposite sign. How to remember this thing? How to remember this condition? If you get negative, that means interval is okay. That means we don't need x2. If it is negative, that means interval is correct. We don't need x2 now. That means x2 will be replaced by x3. That means new search interval, SI. New search interval is, पहले क्या था? x1, x2. Earlier it was x1, x2. But now what is the new search interval? x1 will remain same, but x2 is replaced with x3. x2 is replaced with x3. So this is our new search interval. That is x1 remains same. What was x1? 0. See, x1 was 0. That means x1 equal to 0 itself. But now what will be x2? x2 is replaced with x3. And what was x3? 0.5. That means x2 equal to 0.5 now. I hope it is clear. Now see what happened. We started with the interval 0, 1. We started with the interval 0, 1 in iteration number 1. Now for iteration number 2, what is our new interval? 0, 0.5. See, half of the interval is there now. If we see on the number line, earlier we have 0, 1, this range. But now we need to find our answer only in between 0 and 0.5. So this process will continue. See, again, it will become half, it will become half. So at some point, you will reach at a single point, and that single point will be our solution. Clear? Now, we are going to start with iteration number 2. For iteration number 2, these are the new values. Write down over here iteration number 2. Now same process. How? See, firstly write down x1, then write down x2, then again write down fx1. Now don't find fx1 again. fx1 means f of 0. You had already found f of 0. Where? This one. 1. And again write fx2. fx2 means f of 0.5. You have somewhere f 0.5. See this one. Minus 1.375. Minus 1.375. Done. Same process. Again find x3, x1 plus x2 divided by 2. x1 is 0. Now don't take x2 as 1. Clear? Now x2 is 0.5 divided by 2. And this will be 0.25. You can underline, you can make a box around every value of x3. Earlier it was 0.5. Now it is 0.25. Clear? Now see, same condition we have to consider. Consider this one, same condition. fx1 multiply by fx3, but with the new values. Don't consider the values of iteration number 1. Clear? Now fx1 into fx3. Now see the sign. fx1 is positive. But before that, we will find fx3 definitely. Firstly, find fx3. fx3. That means f 0.25. How to find? By using again equation number 1. That means 0.25 cube minus 5 into 0.25 plus 1. Now, for this, you need calculators. F of x3. If anyone is doing, he or she can tell me. I have f of 0.25 as will anyone find? Minus 0.234375. Minus 0.234375. If anyone is getting different value, you can tell me.
No, ma'am. Right value.
Okay. Now see the same working rule. Consider fx1 multiply by fx3. We don't need the value. We only need the sign. See, fx1 positive, fx3 negative. When you will multiply both of them, you will get negative sign. Again negative sign. This means what? Replace x2 with x3. That means new search interval is x1 comma x3. That means new search interval is x1 and x3. Clear? I am going to erase left hand side. So this is about iteration number 2. Now see, for iteration number 3. For iteration number 3, what will be x1? x1 will remain same. What was x1? 0. But what will be our new x2? x2 is replaced by this x3. And what is x3? It will become x2, 0.25. See? Clear? Now, we have to deal in the interval 0.25. Same working rule. You can write down fx1 again. That means f of 0. No need to find again. You had already written 1. fx2 f of 0.25. We already know this value here. F of 0.25 minus 0.23437375. Clear? Whenever you start any iteration, you need to verify that one value should be positive, another should be negative. It is not always true that fx1 will be positive and fx2 will be negative. Clear? It may be that fx1 is negative and fx2 is positive. In the start of every iteration, when you write these starting values, please clear yourself that one value is positive and another value of the function is negative, not value. Rather, the value of the function is of opposite sign. Clear? Again, find fx3, x1 plus x2 divided by 2, 0 plus 0.25 divided by 2, it will give you 0.125. Clear? So 0.125, find the value of fx3 at this particular point. fx3, f 0.125. From where? From equation number 1. X cube minus 5x plus 1. That means the value of fx3 is, I have 0.37695. 0.37695. You can use scientific calculators in exams also. Whether MST or final exams, calculator is allowed. 0.37695. Clear? Now see, again the same condition. Consider fx1 with multiplied by fx3. Now there is some difference. fx1 is positive, fx3 is also positive. That means after multiplication you will get positive. Clear? Now new search interval. It will be kya banega? Now condition is not satisfied. They should be negative. Now x1 and x3 are in same direction. That means these two values cannot be taken. That means we have to neglect x1. That means x1 will be replaced with x3 and x2 will remain same now. This is very important step. Now new search interval is x3, x4. Sorry, x2. And let us start with iteration number 4. In iteration number 4, what is x1? x1 is replaced by x3. That means x1 became 0.125. And what is x2? x2 is same. What is that? 0.25. Clear? Now one more thing. You have to compare the answer after the end of every iteration. See, in iteration number 2, what is x3? 0.25. You have to compare the value of x3 only. 0.25, 0.376. Nothing is repeated after decimal place. See, 0.2, 0.3. That means you need to continue. Okay, वैसे तो we are given in the statement we have to perform 5 iterations whether the answer is repeating or non-repeating. But still we need to check whether the answer repeats itself or not. See, 0.2, 0.3, nothing is repeated. That means we need to continue. Again the same steps. You can write down fx1 again. That means f of 0.125 and 0.125 is this one, 0.37695. And in the same way, fx2 means at 0.25 and it is somewhere you had found this one, see, minus 0.23, minus 0.234.
Hello, ma'am.
Yes.
Hello, ma'am.
Yes, yes.
Ma'am, in the iteration 4, x1 will be changed, ma'am.
Please repeat again.
Ma'am, in the iteration 4, x1 is changed, ma'am, because in the iteration 3, x1 is equal to 0, and iteration 4, ma'am, x1 is equal to 0.125. Why, ma'am?
Aslam, please speak slowly and speak again. I'm not able to understand what you are saying in iteration number 4.
Yes, ma'am. In iteration number 4, x1 is ma'am different from x3.
X1 is different from X3.
Yes, ma'am.
This one?
Ma'am, x1 is different from x3, ma'am. Why?
X1 is different from X3.
Yes, ma'am.
यस मैम वो कह रहे हैं कि x3 कैसे रिप्लेस हो गया मैम x1 के
बेटा
साथ
जब मैंने आपको वर्किंग रूल लिखवाया असलम लिसन टू मी इन द वर्किंग रूल प्लीज सी स्टेप नंबर 4 in your notebook. If you have written, please see step number 4, or let me write down once again. Step number 4 was, you have to remember these conditions. In the starting, we take x1 comma x2. Now what is the condition? If fx1 multiplied by fx3 is less than 0, then interval will be x1 comma x3. That means x2 will be replaced by x3. And if fx1 multiplied by fx3 is greater than 0, in this case, new search interval will be x3 comma x2. That means x1 will be replaced by x3. Now in our question, it was positive. That's why this is the new search interval. Is it clear, Aslam?
Yes, ma'am. Clear.
Okay. Remember this thing. It is very important. You need to use one of them in every iteration, at the end of every iteration.
Ma'am,
Yes.
iteration will be given in the question. How many iteration we have to find?
Iteration is?
Given, ma'am, how many iteration we have to find in the question?
No, it is not given. Since it is the first question, so that's why we are given in the statement that we have to perform only 5 iterations. But it is not always given. Sometimes question goes up to 10, 12 iterations.
Ma'am,
Okay?
it depends totally on you. How many you have to find?
No,
How can we know, ma'am?
No, it depends on the question. How long we need to continue. That's why I am saying compare the value of x3 at every step. Compare the value of x3 with the previous value of x3 at the end of every iteration. Clear?
No, ma'am. It depends on, ma'am, decimal value.
Decimal value. Before point, it should be same. Definitely, it should be same. But after decimal, at least 2 places should be same. At least 2 places. And sometimes it happened that to make 2 places same, we go for 10 to 12 iterations also. It is a lengthy process.
Okay, ma'am.
The only thing is that it is one of the simplest method. Why? Because we are repeating the same steps again and again and again. No doubt it is lengthy, but it is one of the easiest method. Okay, so let's continue with iteration number 5 now. We were here at iteration number 4 right now. Iteration number 4. fx1, fx2. Now let's find x3. How to find x1 plus x2 divided by 2? That means 0.125 plus 0.25 divided by 2. That means the value
0.31
Faizan, you are not audible, beta.
Ma'am, 0.03125.
0.03125.
03, ma'am.
Anyone else? Anyone else? It is 0.1875, beta. How can you reach at 0.03? That will be out of the range. Your x3 will always lies in between x1 and x2. Please remember, please note it down. x3 always lies in between x1 and x2. So 0.03 is outside this range. So this shows you that the value is incorrect. Clear?
0.1875.
G, bilkul. So let's find fx3 now. How to find? From equation number 1, x cube minus 5x plus 1. You need patience to solve this question. I am saying in the starting. Till now we have done only 4 iterations, but some will go up to 10 to 12 iterations sometimes. Otherwise, 7 to 8 iterations are very normal. So you need patience to solve this question, and you also need speed to solve the question. And now fx3 is 0.1875. I have 0.069092. Is it 0.069092? Now let's check the condition. fx1 multiply by fx3. fx1 is here positive. fx3 is also positive. After multiplication, you will have positive value. That means now Aslam, you can see again new search interval. Both are of positive sign. Repeat step number 4. That means x1 will be replaced by x3 and x2 will remain same. Clear? For the next iteration number 5, x1 will be x3 now. That means 0.1875. But x2 will remain same. That means 0.25. Clear? Now, how we will check that we have arrived at the answer or not? Compare the value of x3. Earlier it was 0.125. See, now it is 0.1875. Up to 1 decimal place, it is repeating 0.1, 0.2. Clear? In this particular question, we are given in the statement that perform only 5 iterations. But let us suppose we are not given in the statement to perform 5 iterations. Then after the end of every iteration, we need to compare the value of x3 in 2 consecutive iterations. Consecutive means we cannot compare iteration number 4 with iteration number 2 or 1. Consecutive means 3 with 4, 4 with 5, 5 with 6 and so on up to. In iteration number 3, we get 0.125. The value of x3 we need to compare. And here we are getting 0.1875. That means it is repeating only up to 1 decimal place. But at least 2 decimal places should be same. Please note it down by making a chart. At least 2 decimal places should be same. Decimal places means digits which are after decimal. Please note it down. Clear? Okay, now let's write down our last iteration. Let's write down fx1 again. fx1, that means 0.1875 value. This one 0.069092. And what about fx2? Value of the function at 0.25. This one minus 0.234375. Minus 0.234375. Let's find x3, which is x1 plus x2 by 2. 0.1875 and 0.25 divided by 2. That means the value of x3 is 0.21875. 0.21875. Let me repeat again that x3 will always lies between x1 and x2 of that particular iteration. Clear? Now let's find fx3. fx3, that means 0.21875 cube minus 5 times 0.21875 plus 1 from equation number 1. And fx3 is, you can make a square or rectangle at every value. I have fx3 as minus 0.0832. Minus 0.0832. Clear? Now let's consider fx1 into fx3. Let's check what is fx1. It is positive. What is fx3? It is negative. That means new search interval is what? X1 will remain same and X2 will be replaced by X3. That is new X1 is same 0.1875 and new X2 is X3 0.21875. So we will stop here. Since in the statement we were given perform only 5 iterations. I hope it is clear to everyone.
Yes, ma'am.
Now,
Clear, ma'am.
let's think that we are not given in the statement that perform only 5 iterations. And let's check whether we need to continue or not. Let's compare the value of x3. See, 0.18, 0.21. The difference is very small now. What is happening in bisection method? We started with the interval 0, 1 and we reach at the interval after 5 iteration 0.1875, 0.21875. See the difference? Now the difference between these two values is very low. It is of 0.03 near about. Earlier the difference was of 1. है ना? So this is what bisection method says. Interval will become half every time and you will reach at a particular value. Clear? Now I want to continue with one more iteration because after doing iteration number 6, you will see the change in the answer. So let us start from here, iteration number 6. Clear? Not given in the statement, but I am going to do because we will reach at the solution. Let's write fx1 0.1875. What was the value? The value was this one 0.069092. And what about fx2 at 0.21875? This value minus 0.0832. Let's find x3, x1 plus x2 upon 2. That means 0.1875 and 0.21875 divided by 2. And you are getting x3 as 0.203125. 0.203125. Now see, look at the screen. Let's compare the value of x3. Earlier it was 0.21. Now it is 0.20. Are you getting? That means up to 1 decimal place we have got the same value 0.2, 0.2. This is up to 1 decimal place only. Clear? If you will continue with iteration number 7, you will definitely get your answer up to 2 decimal places. This is for sure. I am again repeating. Till now we have reached at 1 decimal place. But when you will continue with iteration number 7, you will get same value up to 2 decimal place. But abhi ke liye, for the time being, since we were given in the statement that perform only 5 iterations, so how we will write down our final answer? Therefore, x is equal to 0.2. The value which is repeating itself, not the complete value. The value which is repeating itself. X equal to 0.2. You can write down the word approximately is the required solution. Therefore, x equal to 0.2 approximately is the required solution.